Hello everyone, my name is Fatma Zehra Uğur. I'm a freshman industrial engineering student at Bilkent University. Today I will present you my Physics 102 lab project. The aim of this project is to observe how the electric current flowing through a conducting wire and the length of the wire affect the magnetic field. The materials required for this experiment are conducting wires of 4 different lengths, connection wires, a multimeter, a Gauss meter, a DC power supply, and a ruler. The experiment mainly consists of 3 steps.
First, to be able to calculate experimental magnetic field, I set up a circuit. I set up the circuit by connecting the DC power supply, the multimeter, and the conducting wire in series using connection cables. And also, to calculate the theoretical magnetic field, I used the given theoretical physical formula and the informations. Secondly, while keeping the electric current and perpendicular distance from the wire constant, I connected 4 copper wires of different lengths to the circuit one by one and measured the magnetic field they produce using a Gauss meter. As you can see from the video, while keeping the current of the circuit constant at 3.49 amperes, I connected a 20 cm copper wire to the circuit and observed that the magnetic field produced by the wire was 0.3 Gauss. After repeating this experiment for 20, 25 and 30 cm wires, I obtained the following table. By comparing the theoretical and experimental results in this table, I observed an error percentage of 14.29 for each case. And finally, I selected 20 cm copper wire and connected it to the circuit. Then, by increasing the current value from the DC power supply, I measured the magnetic field produced by the wire for each current value using a Gauss meter. As you can see in the video, using the 20 cm wire, I first set the current of the circuit to 3.5 amperes and observed that the magnetic field produced by the wire was 0.3 Gauss. Then, by increasing the current to 4 amperes, I observed that the magnetic field produced by the wire was 0.4 Gauss. After repeating this experiment for currents of 4.5 and 5 amperes, I obtained the following table. By comparing the theoretical and experimental results in this table, I observed an error percentage of 14.29 for a current of 3.5 ampere, 11.11 for 4.5 ampere, and 0 for both 3 and 5 ampere currents. These errors also caused the baseline in the first graph to appear slightly tilted, and the baseline in the second graph not to pass through the origin, and the possible sources of these errors include the Gauss meter being affected by surrounding magnetic fields, measurement inaccuracies arising from the instruments used, and human errors during the measurement process.
The physical background of this project is based on the fact that magnetic field is produced by the moving electric charges, and as the current increases, the amount of the charges passing through a given cross-section of the wire per unit time is also increases. And since the magnetic field is a local effect, it is independent of the length of the wire. Thank you for watching.